Hi, I'm Brian. Today I'm here to give a story about our business. Our business purpose is to prepare our citizens on Earth for our potential future lives, which is living on Mars. We're using 3D printer to build material for housing on Mars that prevent radiation. Since successful CEOs such as Jeff Bezos and Elon Musk emerge, a lot of business industries are mostly focused on rocket science to prepare for life in the outer realms of the universe. These two are the people who are even thinking about space tourism, which sounds crazy to many skepticals. In order to make it happen, universal citizenships are necessary because we need the people's support. While I was researching on Mars, there are many new challenges new sellers like to face. The product Aeromos is created in order to resolve this issue. First, it would be the importance of our product performance. Since it is a product development that considers astronauts' long-term life in space, it is essential to block space radiation that directly connects life. It is also essential to implement thermal insulation functions that will protect against large temperatures on Mars and key functions of mechanical strength that will not be broken by external impacts. Our main goal is to build a house that prevents space radiation because neutrons and protons and space radiation risk people's health, such as increasing cancer rate, burns your skin, and more.
As mentioned previously, our ultimate goal is to come up with an innovation that can solve the above problems. In addition, as our project is for the safe construction of houses in space, we focus on a few scientific aspects and productivity. The three main issues that we addressed are thermal insulation, space radiation, and the transportation and construction of manufacturers in space. Thus, we have found a chemical that can resolve our scientific aspects, aerogel with polyethylene and boron nitride, and came up with the idea of building through 3D printing for the best productivity. Thermal insulation and flexibility are already very well discussed topics regarding space exploration. We focus on finding the best chemical compound which will protect us from many problems when living in the universe caused by an unidentified range of temperature. Regarding the temperature issue in the space between day and night, aerogel is a good insulator with low conductivity. In addition, organic polymer aerogel, such as polyethylene aerogel, having the property of flexibility, shows strength as being used as the base for house construction instead of brittle silica aerogel. As well as thermal issues, space radiation shielding is another prominent issue to solve. Because neutrons and protons penetrate cells, bones, and metals, it appears that humans' disease and failure, even on electronics, parts after the exposure in space. For anti-radiation, which is another major problem faced on Mars, we have come up with the chemical polyethylene and boron nitride providing greater physical radiation shielding. It is found to be the most suitable material in space housing. Lastly, minimize the weight and volume of materials. Another factor that we considered important was the way of transportation. As the building will be impossible to move as the final sculpture, instead, we came up with the idea of making it there. Hence, our final thought was to bring the 3D printing technique of injecting an air jet system to make mesophores with filament composite and start building on Mars as a lightweight multifunctional system that can reduce the weight and volume of materials from Earth. We may, therefore, reasonably conclude that the solution was designed to solve the pains of spacemen facing on Mars for these unique key features.
Now, let's talk about what aerogels are. Aerogel is a synthetic porous ultralight material derived from a gel in which the liquid component for the gel has been replaced with gas without significant collapse of the gel structure. Aerogels are produced by extracting the liquid component of a gel through supercritical drying or freeze drying. Aerogels are known as the lightest solid on Earth. In space, there are different types of radiation such as X-ray, gamma ray, solar flare neutrons from the sun, and etc. Because it takes more than 1 year to travel from Earth to Mars, the hazard of space radiation is a critical grounding threat. However, the magnetic field of Earth protects us against hazardous radiation. A space shelter like this will shield astronauts and you civilians. Polyethylene aerogel serves as a shielding material of space radiation as a solution. Because it has high hydrogen content and hydrogen atoms are good at absorbing and dispersing radiation, as the material of the housing lead is too heavy, although shielding ability is effective. The weight and volume of materials are important factors to choose for the transportation cost from Earth too. the scientific basis for chemicals that we decide to use will be explained by citing the paper shown on the screen. In a paper reported in the Composites Communications Journal, neutron flux reduced using high-density PE and boron nitride. Hydrogen-rich materials are effective shielding materials against neutrons. As a result, the neutrons and Humphrey rays were stopped by the multi-layer interfaces when the scattering, absorption, and dissipation process is repeated. Now, to talk about the technical concept, we first are going to use PE, and at around 150 Celsius, we're going to mix it with boron nitride powders. And after mixing, we're going to cool the substance to make PE boron nitride filament, and next we will send the filament that is made on Earth to Mars. Then with the 3D printer that is on Mars, we're going to melt the filament by putting in the gold nozzle part. And when putting the filament in the nozzle, we're going to rotate the filament in at 1 RPM and put 180 Celsius of air in it. The melted film in which mesopores are dispersed inside of the nozzle and cooled to form the desired shape with 3D printing.
According to TRL so-called technology readiness level created by NASA, our current development is level 2. In the future, we will accomplish level 5 through patents transfer and level 8 through M&A. Finally, manufacturing our product fulfill level 9 after Series A investment. The global insulation market size was $58 billion in 2020. You can see our segmented SOM market size as mentioned on the screen. About business model. In the insulation market using aerogel, existing companies are already taking the lead, so there's no competition to succeed in business operation with sales profits after manufacturing the same product. Therefore, our company aims to be a research-oriented company that targets the niche market which is not targeted by aerogel companies and realize profits through patents and incorporated M&A. Business model through product manufacturing plans to establish a new strategy according to market situation after Series A when the company has grown in size. The first year's costs and expenses are like this data. About the financial budget, we're targeting the initial investment from angels and accelerators investments and plan the governmental research grant for the second year. Other potential applications of aerogel in aeronautics and space exploration can be cryo tank insulation, rovers, heat shielding, antenna substrates, EVA suits of astronauts, and so on. There are competitive companies such as Cabot, Aspen Aerogel, BASF, and Blue Shift Materials, but their products differ from our product. For the Conrad Challenge, we get together with CEO Hojun, which is me, CEO Doman, CMO Brian, and CTO Jung-Yoon. Thank you.